This module will explain the Android architecture and how each component is vital in managing the Android operating system and its applications. Android architecture consists of different components to support the needs of Android devices. The main component of the Android architecture are as follows: Linux Kernel, Android Runtime, core libraries, application framework, and applications. Now, let us discuss each of the components one by one in detail. Linux Kernel. Android software contains an open source Linux kernel with collections of several C or C++ libraries exposed through an application framework service. Like any other operating system, the Linux kernel is one of the vital part of Android's architecture. It is at the entire system's root or lowest level. It manages all the essential drivers required for the proper functioning of an Android device, including those for the display, camera, audio, Wi-Fi, and memory. The following are some of the main characteristics of the Linux kernel. Security. The Linux kernel ensures that an application and the host system are secure. Memory management. The kernel manages memory well, so we do not have to worry about allocating memory while making applications. Process management. The kernel effectively manages the workflow or the process and allots resources as necessary for processes. The kernel can handle network communications effectively and efficiently. Multitasking. Preemptive multitasking is the most important feature of Linux. It allows multiple processes to share the same processors, CPUs, and other resources simultaneously. It is a multitasking operating system with an asynchronous execution. Android has evolved a great deal since it was released. The Linux kernel it runs on has evolved with it too. Android Runtime. The Android Runtime is a managed runtime used by applications and certain system services on the Android platform. Both ART and its predecessor Dalvik were initially developed with a primary focus on serving the needs of the Android project. ART combines ahead of time, that is AOT compilation, and just-in-time JIT compilation techniques to translate the application's bytecode into native machine code that the device's processor can execute. Dalvik initially implemented the Android runtime in Android, which utilized the just-in-time compilation to optimize RAM usage due to its limited availability. It employed a hybrid approach where the compiler acted like an interpreter, compiling small portions of code during app execution. The ART was introduced to enhance the performance of Android, bringing in ahead-of-time compilation. With AOT compilation, the code was compiled before running the app instead of interpreting it at runtime. The change improved runtime performance but led to longer installation times and increased RAM usage. To address these concerns, Android N reintroduced JIT compilation into AR along with profile-guided compilation. This approach enabled better performance by selectively optimizing frequently executed sections of code based on runtime profiling. Profile-guided compilation continuously enhances the performance of Android applications as they are being executed. Core libraries. Different Android system components use a set of C or C++ libraries in the platform libraries. The Android application framework shows developers how to use these features. Here are some of the most important core libraries. The System C library is a version of the standard C system library based on BSD and set up for embedded Linux-based devices. Media libraries, which are based on Packet Video's open core, can play and record many popular audio and video formats as well as static image files such as MPEG-4, H.264, MP3, AAC, AMR, JPG, and PNG. The Surface Manager decides who can use the display subsystem and combines 2D and 3D graphic layers from different programs to look like they belong together. LibWebCore is a modern web browser engine that runs the Android browser and a web view that can be embedded. SGL is the 2D graphics engine that is used. OpenGL ES 1.0 APIs are used to build the 3D libraries. These libraries either use hardware to speed up 3D rendering or the highly optimized 3D software rasterizer that comes with them. FreeType is a way to show fonts in bitmap and vector formats. SQLite is a relational database engine that all applications can use. It is both powerful and light. The application framework is a crucial component in Android that provides classes to create applications, including a generic abstraction for hardware access and managing user interfaces through application resources. It includes services like Activity Manager, Notification Manager, Package Manager, and View System that aid application development based on specific requirements. Developers can utilize device hardware, access location information, run background services, set alarms, add notifications to the status bar, and more. Applications comprehensive and flexible set of views that can be utilized to create various user interface components including buttons, text boxes, lists, grids, and even an embedded web browser. Content providers that facilitate accessing data from other applications such as contacts or sharing their data. A resource manager that allows access to non-code resources such as localized strings, graphics, and layout files. A notification manager that enables all applications to display customized alerts in the status bar. An activity manager that governs the life cycle of applications and provides a common navigation backstack. These services and systems are integral to the development and functionality of Android applications and serve as a foundation upon which developers can build and customize their applications. Moving on to our next topic, application fundamentals. Android applications are typically developed in the Java programming language. Once the code is compiled along with any required data and resource files, the APT tool bundles them into an Android package, archives the file marked with an APK suffix. This APK file is used to distribute and install the application on the device. In Android, each APK file is considered one application with all its code within it. By default, each application runs in a separate Linux process. When the application's code needs to be executed, Android starts the process and shuts it down when the code is no longer needed. Let's discuss the components of the application. The components of an Android application are the building blocks of an Android app. They are modular and can be combined to create a complete application. The Android application framework has 4 components: activities, services, broadcast receivers, content providers. Now, let us begin with the first component, activities. An activity is a core component of an application that represents a single screen with a user interface. It manages the user interface, receives and handles user input, and launches other activities or services. For example, presenting a list of menu items users can choose from, or it might display photography along with their captions. The second one is services transition. Services are an essential component of an Android application. It allows developers to perform tasks in the background and handle tasks that do not require user interaction. They provide a way to run long-running tasks, communicate with other components, and manage the life cycle of an application. For example, a download manager service can be used to manage downloads in the background. When the user initiates a download, the service can be started to handle the download and notify the user when the download is complete. Broadcast receiver is a key component of an Android app that can receive and respond to system-wide broadcast announcements sent by the Android system or other applications. These announcements can notify the app about various events such as a low battery level or a new SMS message. For instance, a broadcast receiver can be set up to receive an intent when the network connectivity changes. Once the receiver receives the intent, it can update the app's user interface to display the current network status or start a service to perform background tasks such as syncing the data with a remote server. The app can provide users with up-to-date information and a seamless user experience by responding to these system-wide announcements. The fourth component is content providers. Content providers are a crucial component of a relational database because they enable application data storage. In the Android system, the role of a content provider is similar to that of a central repository in which the application data is stored, and it allows other applications to safely access and modify that data based on user requirements. The Android system lets the content provider save application data in various formats. For example, a music player app can use a content provider to provide access to the device's music data. Other applications can access this data querying the music content provider.